In Active Directory, every change made on a domain controller, whether it's a user modification, a group update, or a password reset, triggers an increase in a special number called the Update Sequence Number, or USN. Think of the USN as a unique counter that keeps track of every single update. This mechanism is crucial because it helps domain controllers determine which changes are new and which ones they've already processed. Without this system, keeping all controllers in sync would be nearly impossible, especially in large organizations where changes happen constantly. USNs are the backbone of how Active Directory replication works. When a domain controller receives an update, it checks the USN to see if this is something new or if it has already processed it. This allows domain controllers to efficiently replicate only the necessary changes, reducing unnecessary network traffic and ensuring that all controllers remain consistent. Without USNs, there would be no reliable way to track which updates need to be shared across the network. Every time a change is made on a domain controller, the USN counter is incremented. This means that each update, no matter how small, is assigned a unique number. Other domain controllers then look at these numbers to decide if they need to pull the latest updates. This process ensures that all controllers are aware of the most recent changes and can act accordingly to stay synchronized. When a domain controller, say DC1, notices that another controller, DC2, has a higher USN than what it last recorded, it knows that there are updates it hasn't received yet. For example, if DC1 last saw DC2 at USN 4800 and now sees 5000, it understands that it needs to pull all updates from 4801 to 5000. This system keeps all controllers up to date without missing any changes. Now let's talk about a critical problem, USN rollback. This occurs when a domain controller's USN counter goes backward instead of forward. Active Directory is designed with the assumption that USNs only ever increase. When this expectation is broken, the replication logic fails, leading to serious issues in the directory's consistency. USN rollback is most commonly caused by actions like reverting a virtual machine snapshot of a domain controller or rolling back a DC system state without following proper Active Directory restore procedures. These actions essentially make the domain controller forget some of its updates, causing its USN to decrease unexpectedly. To understand the danger, imagine DC1 remembers that DC2 had reached USN 5000. If DC2 is reverted to a snapshot and now shows USN 4500, DC1 is confused. It thinks all updates up to 5000 have already been processed, so it ignores any new changes from DC2. This creates gaps in replication and causes the directory data to diverge, leading to inconsistencies across the network. Active Directory uses a mechanism called the high watermark to detect USN rollbacks. Each domain controller keeps a record of the highest USN it has ever seen from its replication partners. If a partner suddenly advertises a much lower USN, the receiving controller flags this as abnormal, indicating a potential rollback. Each domain controller has a unique identifier for its Active Directory database, called the invocation ID. When a DC is restored from a snapshot, its database effectively time travels, but its invocation ID remains the same. Other controllers compare both the invocation ID and the USN to detect if a rollback has occurred. Active Directory combines both the high watermark and invocation ID checks to detect USN rollbacks. If the patterns do not match what is expected, replication is immediately stopped to prevent further inconsistencies. This safety mechanism is crucial for maintaining the integrity of the directory. When a USN rollback is detected, Active Directory generates specific error messages such as USN rollback detected, or the local domain controller has attempted to replicate changes from a partner using an old USN. These errors are clear indicators that something has gone wrong with the replication process. Once a USN rollback has occurred, the affected domain controller's replication state is considered corrupted. Other controllers no longer trust its updates, and even forceful replication attempts are blocked. The only safe solution is to remove the affected controller from the domain and rebuild it from scratch. The first step in fixing a USN rollback is to forcefully demote the affected domain controller. This can be done using tools like DC Promo with the /forcer removal option or its modern equivalents. This step ensures that the problematic controller is removed from the domain safely. After demotion, it's essential to clean up the metadata of the removed domain controller. Tools like ntdsudo are used to remove all traces of the old controller from Active Directory, including stale DNS records. This step prevents future replication issues and keeps the directory healthy. Once the metadata is cleaned, the next step is to rebuild the domain controller from scratch. This involves rejoining it to the domain and promoting it again. By starting fresh, you ensure that the new controller has a clean replication state and can safely participate in the network. To recap, the USN is a change counter on every domain controller. It increases with every update, allowing controllers to track which changes they have and which ones they need. This simple mechanism is the foundation of reliable Active Directory replication. Domain controllers use USNs to decide which updates they still need. By comparing their own records with those of their partners, they can efficiently synchronize changes and maintain consistency across the network. USN rollback happens when a domain controller's USN goes backward, usually due to VM snapshots or improper restores. This unexpected change disrupts the replication process and can lead to data inconsistencies if not addressed promptly. Active Directory detects USN rollbacks using both the high watermark and invocation ID. These mechanisms work together to ensure that any abnormal changes are caught quickly, preventing further replication issues. When a USN rollback is detected, replication is blocked for safety. This prevents the spread of potentially corrupted data and ensures that only valid updates are shared across the network. The only reliable fix for a USN rollback is to demote the affected domain controller, clean up its metadata, and rebuild it from scratch. Attempting to repair or force replication will not resolve the underlying corruption and may make things worse. Let's visualize how USN-based replication works. Imagine two domain controllers, each with their own USN counters. As changes occur, the USN increases. When controllers communicate, they compare USNs to determine which updates are needed. This simple comparison keeps the entire directory synchronized. Now let's see what happens during a USN rollback. If DC2 is reverted to a snapshot and its USN drops from 5,000 to 4,500, DC1 is left confused. It believes it already processed updates up to 5,000, so it ignores new changes from DC2, causing a replication gap. The high watermark logic is a key detection method. Each DC stores the highest USN it has seen from its partners. If a partner advertises a lower USN, the receiver flags it as abnormal, helping to catch rollbacks early. Invocation ID is another detection mechanism. Even if a DC is restored from a snapshot, its invocation ID remains the same. By comparing the invocation ID and USN, other controllers can spot rollbacks and prevent replication errors. When a rollback is detected, replication is blocked to protect the directory. This ensures that no potentially corrupted data is spread to other controllers, maintaining the integrity of the entire system. Demoting the affected domain controller is the first step in recovery. This removes the problematic controller from the domain, preventing further replication issues and setting the stage for a clean rebuild. Cleaning up metadata is crucial after demotion. This step removes all traces of the old controller, including DNS records, ensuring that the directory remains healthy and free from legacy issues. Rebuilding the domain controller involves setting up a new server, joining it to the domain, and promoting it. This fresh start ensures that the new controller has a clean replication state and can safely participate in the network. In summary, USNs are essential for tracking changes in Active Directory. USN rollback is a serious issue, usually caused by improper restores or VM snapshots. Active Directory uses high watermark and invocation ID to detect rollbacks and blocks replication to protect the directory. The only safe fix is to demote, clean up, and rebuild the affected controller. Always follow best practices for backups and restores to avoid USN rollback scenarios.